Next question, find the reason for non-placement from the data set. So before I deep dive into the code, you need to understand the two terms like correlationship coefficient and the p-value. So the correlation coefficient will tell us, so here the predicted variable is the placement. The placement happens based on the student performance and their college percentage degree. So we are going to find the relationship between what's the relationship of the futures with the predicted variable. So okay, so here we can say, here I have the ranking guide as well. So if it is R value is greater than 0.7 means we can say that it's a strong relationship. So if it is 0.3 means to 0.7 means it's moderate. If R value is less than 0.3 means we can say it's a weak relationship. So basically the p value tell us that for the placement which feature contributed more. That kind of information only we can get it from the p value, sorry, correlation coefficient value r. Okay, and the p value will tell us it's a significant test, okay, whether the chances could be very higher. Okay, so if it is 0.0 means it's a statistically significant. What does it mean is the student who were scored higher percentage in their SSLC percentage, it's a high chance for the placement. Let's say MBA percentage, the difference between the MBA percentage is 0.697. Even though it's contributed, the chances are chances are very slim. Okay, that's how we can interpret the data. Okay, so for the correlation coefficient and the p value, we have a different algorithm. So here I have used point biserial or algorithm. So I have calculated the mean by grouping the column by status, and for every futures for the placement column and the non-placement column, and I just printed it. Okay, that's it, the result. So it's straightforward. So here in this table you can see all the features and mean for the placed data set and for the non-placed, and the difference and correlation coefficient and the p-value and the meaning. So here we can say that by looking at the order, we can say that the strongest driver for the placement is SSLC percentage, higher secondary, and the degree. Okay. Okay, let's move on to the next question. What kind of relationship between salary and the MBA percentage? Okay, so here also we need R and P value. So the R stands for correlation coefficient, P stands for the significant test. So here I have used a different algorithm, Pearson algorithm. So with that we can, the result what we got is the R value is 0.189. It has some relationship, but it doesn't show any strong relationship. What does it mean is whoever has scored higher MBA, the chances could be like they may get a higher salary, but it doesn't have a strong relationship. That's what we can interpret. This is how we can interpret the result. Next question, which specialization is getting the minimum salary? Let's see how I coded. So there are two ways we can calculate the minimum salary. One is with the absolute, another one is the median. In this program I coded with the trying to calculate the lowest salary by median. So here we have the placed data frame. So I'm grouping by specialization and calculating the median for the salary column. Okay, and sorting the value and just printed the whichever is the lowest salary, I just printed it. So here the lowest median for the marketing and HR was 2,55,000. For marketing and HR, this is the thing, and marketing and finance, we have 27,000. Okay, let's move on to the next question. How many of them getting above 5 lakh salary? That's what the question. So we have that placed data frame. Okay, so in that placed data frame, I just picked up the salary column, salary feature, and just counting if it is greater than 5 lakhs. I'm just summing up how many data set or data frame has more than 500 and lakh, and then I just printed it. So okay, so here we could see 3 students got more than 5 lakhs.